All right, we got another example. So you throw a baseball straight up in the air and drag force is proportional to v squared. In terms of g, what is the y component of the ball's acceleration when the speed is half its terminal speed as it's moving upwards and then as it's moving back downwards? Okay, so to start with, I need a marker. To start with, we're going to go ahead and draw our free body diagram for each situation. So on the way up, the velocity is up, so the air resistance is opposite that direction of velocity. On the way down, the air resistance is pointing up opposite the direction of that velocity. So I set up my equation as such. So I have mg plus f equals ma. Now I've chose down as my positive direction because that's the direction it is accelerating in. They also told me that this force, this air resistance, is proportional to v squared. So I'm going to put in my dv squared, where d is a constant here. And they told me that v is half the terminal speed. So I am going to have to figure out the terminal velocity here. So terminal velocity occurs when acceleration equals 0. Okay. So in order for that to occur, I just have to say, well, mg has to be the same as dv in a free fall scenario. So those two forces balance, causing that acceleration to be equal to 0. Solve for vt here, and so I get mg divided by d square rooted gives me vt. Okay, so let's plug that in. So I have mg plus d times this thing squared, but it's also half of that thing squared. So this stuff all comes back outside the square root value, and then the 1/2 also squared becomes a 1/4. And so I'm left with d and d canceling out. I also see that the masses cancel out of everything, and so I have g plus a fourth g, so I end up with 5/4 g is equal to the acceleration, which makes sense that the acceleration is going to be more than just g because I also have this air resistance as well. Okay, now doing that same kind of strategy but over here, so now I have mg minus that air resistance equals ma, making those same substitutions, so dv squared equals ma, mg minus d times 1/4 of mg over d equals ma, and I see the d's cancel, the m's cancel, so everything's playing out exactly the same. The difference is here I had a plus, here I have a minus, so instead of adding the fourth, I subtract the fourth, and so I'm left with 3/4 of g is the acceleration, which would make sense because gravity is pulling it down, but the air resistance is repelling that, so it's slowing that acceleration. So there we go.